guys, I hope you're able to draw the situation. We do not want to make this too big. First, I want you to draw just sort of, just a real quick sketch of what's going on. You've got a tower, a water tower, and above it a plane is flying, and it passes directly over the water tower. And you have your house over here. And this is not drawn to scale at all. It's just a quick sketch. Well, sure, doesn't matter. Yeah, it doesn't make any difference. That's good. That's a good question. It doesn't matter which direction you go, guys. It could be the other direction. No, this is fine. And this is at a right angle because it's directly above the water tower. And the angle of elevation is the angle you have to look up to see the plane. This is called an angle of elevation. It's how much you have to look up to see it. And it happens to be 25 degrees. And we know this distance is 5.3 miles. Now you want a very small sketch of this because you're going to use the rest of the space to create a triangle that we're going to use to find these missing pieces. What you're going to do now, I want you to draw a triangle that is exactly 25 degrees and 90 degrees so that we have a similar triangle. Do you understand that it'll be similar? And we can use that similar triangle to find the missing sides. Because we can't use Pythagorean theorem. Do y'all see why? How many sides do we know? We only have one side, but we do have two angles. See that? So I know what the other angle is, don't I? What's this angle up here?
45.
This one's 25, this one's 90, this one is? How much? 65 degrees, isn't it? 65 and 25 makes 90, plus 90 makes 180. What we're going to do, and what I'm interested in, is I want to find a couple of things. I want to find the altitude of this thing, right here. The altitude of the plane, I'll put it in black. I want to find the altitude of the plane in feet, but I also want to find the distance to the plane. Got all that? So what I need is, if I had a triangle that was 25 degrees and 90 degrees, it would be similar to this one. Do y'all follow what I mean? So I'm going to draw a triangle that's similar to this one and use it to find the missing sides. So I'm going to draw a triangle. It does not matter how big you make it. That's what's really cool about this. The bigger the better in general. So what I'm going to do is draw a pretty big triangle. It doesn't have to be humongous, but you want to draw it pretty big. And what angle am I going to put down here?
25.
I'm going to put a 25 degree angle down there. Now be careful. Everybody, I want to show you something. I saw a lot of people doing this. They did this the right way, and they went like that, and they go, oh, 25 degrees, and then they couldn't figure out whether they had a mistake. Well, it does matter, guys. You have to put this line has to go along your line. This has to go on your vertex. You can't do this either. You have to put your vertex at your intersection on your protractor. You have to go along the line. You have to get 25 degrees and mark it, and draw in a nice long side over here. Everybody get that part first. Then I'll show you how to add in the third side. It does not matter how long. What's important is that the angle is accurate. Be very careful with your angle. 25 degrees, yeah. Now when you draw in your 90-degree angle, you could just grab the bottom of a ruler and just estimate it, because the bottom of the ruler is rounded off at 90 degrees. But it's best if you use a protractor because it's going to be more accurate. So watch this, guys. I'm going to take my protractor. I could put it here. Do you see that little intersect? But I could also put it anywhere along here so that I get a 90-degree angle on there. I'm going to put it about as far out as I can. Now I need to make sure that I actually get this along the line on the base, that I mark where it's at. In other words, I mark my 90 degree here and here so I can draw in my line.
We have 16 degrees.
Now as a final check, you can measure your angles and make sure that you're really looking at the right size angles. Grab maybe a different protractor or grab your protractor and check to make sure you're really at 25, 90, and I'm dead on, and 65. Sure enough. Very, very carefully measure the sides of the triangle you just made. Try and be as accurate as you possibly can. The more accurate you are, the closer your answer is going to be. So I'm going to measure this side. It happens to be 16.1. This is my 25-degree angle. This one is 7.2. And this one is 17.9. Your measurements should be different than mine, shouldn't they? Everybody should have different measurements. Measure your triangle. Everybody try it. You need to measure the triangle that you just created. I have 3 sides on these triangles. Everybody look up here for a second. Tell me which one of these sides is the hypotenuse on this. What is it labeled? Distance. This is called the hypotenuse. It's always across from the right angle. Of course, which one's the hypotenuse down here? The longest side, the 17.9 is the hypotenuse. Now you have 2 other sides and they're called legs. Both of them are legs. So you have to identify the different legs because they're different, aren't they? You could say short leg and long leg, but it's better if we say the leg opposite the angle. This is called the opposite leg. And this one is called the adjacent leg. Label the bottom triangle with the same legs. Which one of these is the adjacent leg and which one's the opposite leg for down here? Adjacent, because it's on the angle. This is the adjacent leg. And the one across is the opposite leg. Now what I'm going to do is I'm going to set up some proportions. I want to find the altitude, and using what I know, which 2 am I going to use? The hypotenuse, the opposite leg, or the adjacent leg? Which two? Opposite and adjacent. I'm going to write the opposite leg over the adjacent leg. That is the altitude. I can call it A for altitude, or I can call it H for height, or whatever. It doesn't matter. I'll call it X. The altitude over 5.3. Notice that I wrote opposite over adjacent. So on the other triangle, I need to write opposite over adjacent. What's the opposite side on this one? On mine? Mine's 7.2 over 16.1. You guys have different ones. Yours should be different than mine. Everybody set up your proportion. Your quiz on Friday will look a lot like this. It'll be almost identical. It's going to have one of these, and it's going to have one of the classwork problems. It will definitely have a plane problem in it, and it'll look a lot like this one. It'll have an angle of elevation and all that. I want you to all try something for me. Divide your opposite over adjacent side. Do that division with your numbers. Your numbers should be different than mine, but when you divide them, you should get the same decimal. Let's see if we get the same. I'm going to take mine, 7.2, divided by 16.1. I get something like 0.45. See what you guys get. I get about 0.45. See what yours is?
My battery.
Press a second. Oh. Don't worry about it. If it doesn't turn off, then don't worry. On split screen. Go to mode. Wow, they really
Measure what?
Did everybody get about 0.45 when you divided those?
Which one?
I want you to take the opposite leg over adjacent leg. Yours, not mine. Take your opposite leg divided by your adjacent leg and see if you get something close to 0.45. 0.47, 0.46.
We got to 0.1.
You didn't divide the right way. We're talking about opposite leg divided by adjacent leg. Right again. Got it?
0.4?
0.48, 0.45, 0.47, 0.46. Everybody should be somewhere in around the 0.4s, right? Because the idea is that your triangle is similar. All of our triangles should be similar because they all have the same angles, assuming you drew them correctly. If you're using one of these protractors, you need to highlight these. They're really hard to see, but they do stick out. You can use your pencil to mark them, because if you go along the base edge, it won't work. And if you go in the holes, it won't work. You have to go right in the areas where it shows here. They're really hard to see. Everybody see the green marks I put on this thing? Because if you put it like this, the 25 degrees is going to be off, see? That's why you might have a different number. You have to be really careful with your protractors. All right, cross multiply and solve that. Correct. What you got? This is 7.2 times 5.3. Diego, where's your glasses? Your glasses, where are they? I'm sorry? You don't use glasses. Okay, it looks like you need some. I don't know. I guess maybe it was, I didn't have it focused or something. You were looking at it kind of funny. All right. Divide by 16.1 on both sides, or whatever it is you have. Yours is going to be different than mine. I got 2.4. 2.4 what?
Centimeters.
No.
Feet.
No.
Miles.
Miles. Because we are solving for the altitude and we're using 5.3 miles, aren't we? This is miles? We were using centimeters divided by centimeters, which cancel each other out. Miles divided by miles cancel each other out. This is 2.4 miles. Is that the answer we were looking for? Elevation in feet. So we're going to have to change 2.4 miles. Did y'all get about 2.4 or 2.5? Last class I got 2.5. This class I got 2.4. 2.5, 2.4, 2.6, somewhere in there. Okay. I'm going to change miles to feet. What am I going to put in the bottom?
Miles.
Miles in the bottom. Goes in the top. Feet in the top. This up a little bit so you can see it better. Which one gets the 1?
The mile.
Largest one gets a 1, and how many feet?
3.
No. In a mile. 5280. Yeah, that's feet in the yard that you were thinking of. And the miles cancel out. And we've got 2.4 approximately times 5280. And I get about 13,000 feet. You may get 14,000 feet. I think I got 14,000 last time.
So you round it or what?
Yeah, of course. I need to round it off to 2 significant digits, don't I? Because this is only to 2. And this is only to 2, so I need to round 2 significant digits, about 13,000 feet. Now this is only an estimate, but it should be pretty close. Now we also want to find the exact distance between the house and the plane. It's going to be a little more than 5.3 miles, right? You understand? Because it's going to be the hypotenuse. So this time I'm looking for the hypotenuse. We're going to write a new... Cut this down a bit. I guess I could put it at the top. What I'm going to do now, I want to look for the hypotenuse or the distance. So I'll call it D. And the one I know is the adjacent. So which of those 3 am I going to use? Opposite over hypotenuse, adjacent over hypotenuse, or opposite over adjacent?
Opposite over.
That's what we did last time. Adjacent over hypotenuse. I need to use one of those 3. So my 3 are opposite with hypotenuse. I have adjacent over hypotenuse. And I have opposite over adjacent. This is the one we used on the first problem to find the altitude, because it's opposite and adjacent. This time I'm going to use adjacent and hypotenuse. The adjacent side is 5.3. What's the hypotenuse? D. And in the other triangle, my adjacent? Adjacent, it depends. Mine is 16.1. Yours is going to be different. 16.1 over 17.9. Yours should be different than mine.
Mr. On the other one, 13,000 is the middle name?
Yeah. 13,000 feet. Approximately. Cross multiply and solve it. Why don't y'all try your decimal and see if you get something like mine. I got 16.1 divided by 17.9. I got 0.9. Anybody else get about 0.9? Pretty close?
Mr. What is that for the 44?
Okay. Take the adjacent divided by the hypotenuse. Yours should be different numbers, but when you divide them, you should get the same proportion. You got what? No. Divide the adjacent by the hypotenuse.
Yep.
Take your adjacent side divided by your hypotenuse. You should get something
0.9.
approximate 0.9, don't you? Didn't everybody get 0.9?
Yeah.
That's because, isn't this the same for everybody? Because you have an adjacent over hypotenuse with this similar triangle. Everybody's is similar. That's why it works. Cross multiply, 16.1 D, and everybody's is different again. I'm going to multiply my 5.3 times my 17.9. And I get 94.87. And I'm going to divide that by 16.1. Everybody's is different. D is approximately, now it should be the same. I get about 5.89, 5.9?
Yeah, this one should be.
Okay, everybody should get around 5.9 or 5.8, somewhere around 6. 5.9 what?
Miles.
Miles. This is the distance to the plane. Now, if we wanted to change it to feet or yards, we could do that.